Hello guys, so today we're doing LeetCode question 235, lowest common ancestor of a binary search tree. The question is a medium question and it is, given a binary search tree, find the lowest common ancestor node of two given nodes in the binary search tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. So example 1, the tree has a root node of 6 with a left child node of 2 and a right child node of 8, 2 child nodes of 0 and 4, 8 child node of 7 and 9, 4 child node of 3 and 5. So P is 2, Q is 8. We have to find the lowest common ancestor. So 2 and 8, the common ancestor is 6, as you can see. The first ancestor closest to both. Example 2, we have the same tree. P is 2, Q is 4. So the lowest common ancestor is 2 because 2 can be an ancestor itself and 4 is close to 2. So yeah, the output is 2. Example 3, the root is 2 and 1, P is 2 and Q and 1, so the output is 2 because 2 is the root node. So the way we do this is by using a depth first search with recursion, and we pretty much return the node when we find it. For left, we search for left and right. We turn the left node when we find it, the right node when we find it. And we go back up, and then we return the node that is closest to both. So I'll give you an example here. So this is our tree. Let's say we have P as 2 and Q as 4. So our first root is 6. So we would recursively check the left side first and the right side, and only return when we find both values or one value, if we haven't found both. So first we go to the left side of the tree. We're now at 2. Is 2 equal to P or Q? Yes, it's equal to P. So we return P and we go left. So is 0 equal to P or Q? No. So we go down, this is null, we go back up, we go right, this is null, we go back up, so we go back up to 2. Then we go down to the right side, 4. Is 4 equal to P or Q? Yes, equals to Q. So now we have both P and Q. We go back up here, and we see that 2 has both P and Q. So now we return that node. So we return 2. Now let's give another example. Let's say, what's the first example? The first example was P and Q are 2 and 8. 2 and 8. Okay. So let's say P is 2 and Q is 8. So we know it's 6 again. So let's say we're at 6. Is 6 equal to P or Q? No. So we go left. Check recursively. Is 2 equal to 2 or Q? Yes. So is 2 equal to P or Q? Yes, equals to P. So let's just put an arrow here to say this is P. P here. Then we go again to the left. Is this equal to P or Q? No. This is null. Right is null. We go back up. We go now to the right side. Is 4 equal to P or Q? No. We go left. Is 3 equal to P or Q? No. We go up. Nothing here. Go back down to 5. Left is null. Right is null. Go back up to 4. Go back up to 2. So now we have 2. So we return 2. We go back up to 6. Now we're at 8. So at 8, is 8 equal to P or Q? Yes, it's equal to Q. So now we have both P and Q. We return Q here, and we go back up. Now we have both P and Q here, sorry. So we return this node, because this is the lowest common ancestor of both. So we return 6. So let me show you how it's done in code. So first thing, create a base case. So if there is no root, or root is null, we return null. Then if the node is equal to P or the node is equal to Q, we know we found one of the values, so we return that node. Sorry, not node, root. So root. So, but yeah, if that node is found, we return it. Then we get the left value by searching the left child of the binary tree. So let left is equal to lowest common ancestor, where we pass the root, P and Q. Then we get right, do the same. So lowest common ancestor, root. Sorry, this is root.right, P and Q, and this is root.left. Switch it to left and right subtrees. Then, if we find both left and right, if we have found both at this current node, then we return the root value. Otherwise, we return either left or right, signifying that we found one of them. Now let's run. Let's see this passes, let's submit. Okay, this is normally much faster than that. I'm gonna run again just to show you. Okay, anyway, this is an average time complexity. Obviously, LeetCode runs vary in time, but it will be around this area. This is time complexity of O(n) as we loop through the whole tree, worst case, and the space complexity of O1. Thanks for watching.